This is a monster. Look at the size. I mean, this female, she's definitely bigger than...
Look at the width of that thing.
My goodness. That is amazing.
The ROV camera pans across the silt, filming a world where the pressure would crush a human skeleton in seconds. Everything is still until the darkness moves. A massive, solid shape cuts through the light, its sheer scale dwarfing the equipment. The creature moves with a heavy, prehistoric power, its silhouette suggesting the return of the Megalodon. You think it's just a sighting, but it's a direct challenge to what we think we know about the trench. Let's look at the original king of the abyss that was suspiciously seen in the deep trench of Mariana. The true Megalodon. First, we strip away the cinema screens and the digital effects to look at the cold, hard biology of the Otodus Megalodon. Because, let's be honest, you're thinking of that gigantic shark Megalodon from the movies, right? This was not merely a larger version of a great white shark. It was a specialized evolutionary masterpiece that redefined what it meant to be an apex predator. When we talk about the Megalodon, we are talking about a creature that dominated the global oceans for roughly 20 million years. To put that in perspective, modern humans have been around for a mere fraction of that time. The Megalodon wasn't just a successful species, it was a global empire. The first thing that demands attention is the sheer physical scale. Based on the fossilized teeth found on nearly every continent except Antarctica, scientists have reconstructed a predator.
Scientists have been left to reconstruct Megalodon's history, a few fossil and teeth
that likely reached lengths of 15 to 18 meters. Some outliers even suggest 20 meters. To visualize this, imagine a standard school bus. Now imagine two of them parked end to end, covered in muscle, and capable of moving through the water at high speeds. This size wasn't just for show. It allowed the Megalodon to maintain a higher body temperature than the surrounding water, a trait known as regional endothermy. This warm-bloodedness gave it a massive advantage, allowing it to hunt in colder waters and move with more explosive power than its cold-blooded prey. However, a body that size requires a staggering amount of fuel. The Megalodon was a metabolic furnace. Estimates suggest that an adult would need to consume over 1,200 kilograms of food per day just to maintain its energy levels. This brings us to the mechanics of the hunt. The Megalodon didn't just bite, it obliterated. Its jaw was a complex arrangement of cartilage and muscle that could exert a bite force of approximately 108,000 to 182,000 newtons. For comparison, a great white shark snaps its jaws with about 18,000 newtons. The Megalodon possessed nearly 10 times that power. It was designed to crush the rib cages of small to medium-sized whales, snapping bone like dry kindling. The teeth themselves are the primary evidence we have left behind. Unlike human teeth, which are rooted in bone, a shark's teeth are part of a conveyor belt system. Throughout its life, a single Megalodon could go through thousands of teeth. These weren't the thin, needle-like teeth of a fish eater. They were thick, robust, and heart-shaped, with fine serrations along the edges. The Latin name Megalodon literally translates to big tooth, and it is an understatement. Some specimens exceed 18 centimeters in length. The thickness of the tooth was critical. It needed to withstand the immense pressure of those 182,000 newtons without shattering against the vertebrae of a bowhead whale. Evolutionary biology also tells us that the Megalodon was a master of its environment. It thrived during the Miocene and Pliocene epochs, a time when the oceans were teeming with slow-moving cetaceans. The world was its buffet. It didn't have many competitors, though it did share the seas with the Leviathan.
It was not the only super predator terrorizing the seas. Megalodon shared waters,
A prehistoric sperm whale with teeth the size of chihuahuas. These two giants likely engaged in one of the most violent rivalries in Earth's history. But the Megalodon had the edge in terms of distribution. It was a cosmopolitan species, found in both deep offshore waters and shallow coastal nurseries, where the young could feed on calves. The skeletal structure of the Megalodon, though primarily made of cartilage which doesn't fossilize well, was likely incredibly dense to support its massive muscle mass. We know this because of rare discoveries of fossilized vertebrae. These centra show us that the shark's spine was thick enough to act as a powerful spring, loading up energy and releasing it through the tail. This made the Megalodon a formidable pursuit predator. It wasn't just lurking, it was patrolling. It had a wide, blunt snout, likely filled with an advanced sensory array known as the ampullae of Lorenzini, allowing it to detect the faint electromagnetic pulses of a whale's heartbeat from miles away. Despite this perfection, the fossil record tells us that things began to change about 3.6 million years ago. The planet was cooling. The Isthmus of Panama closed up, shifting ocean currents and causing the Megalodon's primary prey, small whales, to migrate to colder polar waters. A massive, warm-blooded predator needs consistent, calorie-dense food sources. As the whales moved toward the ice, the Megalodon faced a crisis. Its massive size, once its greatest strength, became a liability. It couldn't follow the whales into the freezing polar seas without losing its metabolic edge, and the remaining food sources in the warmer tropics weren't enough to sustain a 50-ton frame. This transition from global dominance to a sudden disappearance in the fossil record is what fuels the mystery. If the Megalodon was so perfectly adapted, could it have found a way to survive? Some theorists suggest that rather than dying out, a small population might have adapted to the deep, following a different evolutionary path. This would require a radical shift in biology, slowing down the metabolism, changing the diet, and learning to survive the crushing pressures of the Hadal zone. It sounds like science fiction, but the ocean has a way of preserving things we thought were long gone. When you look at the footage from the Mariana Trench, you aren't just looking at a large fish. You are looking at the potential continuation of a lineage that was once the undisputed ruler of the planet. If that shadow is indeed what it appears to be, it means that our understanding of extinction and adaptation is missing a massive piece of the puzzle. But how could a creature built for the sunlit surface survive in a place where the sun never reaches? Life at 36,000 feet. The Mariana Trench is not just a hole in the ocean floor. It is a vertical wilderness that defies every biological rule we understand on the surface. Located in the western Pacific, this crescent-shaped scar in the Earth's crust reaches depths of approximately 11,000 meters at its lowest point, known as the Challenger Deep. To visualize the scale, if you flipped Mount Everest upside down and dropped it into the trench, there would still be over 2 kilometers of water above its peak. This is the Hadal Zone, named after Hades, the king of the underworld, and the name is fitting. It is a place of perpetual darkness, freezing temperatures, and a pressure so intense it behaves like a physical wall. At these depths, the weight of the water column above exerts a pressure of roughly 15,000 pounds per square inch. For a standard organism, this would mean immediate structural failure. Cell membranes would become squeezed into a solid state, and proteins, the building blocks of life, would fold and collapse, rendering biological functions impossible. Yet, as our ROV cameras have shown, life does not just exist here. It thrives. This brings up the first major hurdle for a creature like the Megalodon, the engineering of survival. If a prehistoric predator moved into these depths, its entire molecular biology would have had to undergo a fundamental redesign. Most deep-sea residents have replaced the air-filled spaces in their bodies with non-compressible fluids and fats. They possess specialized molecules called piezolites, which act like chemical scaffolding to prevent their proteins from being crushed by the weight of the abyss. This is why many deep-sea fish look melted or gelatinous when brought to the surface. Their bodies are held together by the very pressure that would kill us. For a megalodon, a creature characterized by massive muscle density and a rigid, powerful frame, the transition to this environment would be an evolutionary marathon. It would mean trading the explosive speed of a surface hunter for the slow, energy-efficient endurance of a deep-water scavenger. The temperature at the bottom of the trench hovers just above freezing, usually between 1 and 4 degrees Celsius. In the science of the Megalodon, we noted that its regional endothermy, its warm-bloodedness, was its greatest weapon. In the Mariana Trench, that weapon becomes a death sentence. Maintaining a high body temperature in 1-degree water requires an astronomical amount of calories, and the deep ocean is famously a food desert. Most life down there relies on marine snow, a constant drizzle of organic detritus, dead plankton, and fecal matter drifting down from the productive surface layers. This creates a bottom-heavy food chain, where the biggest meals are whale falls, the carcasses of large whales that sink to the floor, providing a localized feast for years. However, the lack of food has led to a fascinating phenomenon known as abyssal gigantism. For reasons scientists are still debating, some invertebrates and fish grow to massive sizes in the deep. We see this in the giant isopod, which looks like a pill bug the size of a cat, or the colossal squid. The theory suggests that larger bodies are better at storing energy and can travel longer distances between rare food sources. This provides a glimmer of biological hope for the Megalodon theory. If the deep ocean favors larger, more efficient bodies, perhaps a massive shark didn't just survive there, it became the ultimate expression of the deep-sea giant. The geography of the trench also provides a perfect hiding spot. It is a complex landscape of tectonic plates, volcanic vents, and hydrothermal chimneys. These vents are critical because they pump out mineral-rich, superheated water, creating oases of life that don't depend on sunlight. Around these vents, bacteria convert chemicals into energy, supporting entire ecosystems of tube worms, crabs, and fish. If a large predator were to patrol these vent fields, it would find a consistent, albeit localized, source of heat and food. This creates a patchwork habitat where a prehistoric survivor could potentially leapfrog from one food source to the next, staying out of the reach of human observation for centuries. The darkness itself is the final barrier. In the Mariana Trench, there is zero sunlight. Creatures here have either evolved massive, hypersensitive eyes to catch the faint glow of bioluminescence, or they have abandoned sight entirely in favor of other senses. A shark, already equipped with the ampullae of Lorenzini to detect electrical fields and a lateral line system to feel vibrations in the water, would actually be well suited for a pitch-black hunt. It wouldn't need to see its prey. It could feel the rhythmic displacement of water from a swimming fish, or the faint electrical hum of a crustacean's nervous system from hundreds of meters away. When we see a massive shadow in a video from these depths, we are looking at something that has solved the most difficult engineering problems in nature. It has found a way to resist the crushing weight, to operate in a refrigerator-like environment, and to hunt in a void. The trench is a world of silence and slow motion, a stark contrast to the chaotic, sun-drenched surface waters where the Megalodon first earned its reputation. It is a frontier that remains 95% unexplored, a vast, three-dimensional labyrinth that could easily swallow a dozen species of giants without us ever being the wiser. This leads to a crucial question of identity. If something that large is moving through the darkness of the trench, and it has adapted to the crushing weight and the cold, is it still the Megalodon we know from the fossils, or has the abyss turned it into something else entirely? To find out, we have to look closer at the other giants that we know for a fact are patrolling those depths right now. But are these shadows the ghosts of the Miocene, or are they modern monsters we are only just beginning to recognize? Interpreting the giants. When a massive, ghostly shape glides across the lens of a deep-sea camera, the human brain is hardwired to jump to the most dramatic conclusion possible. We want to see the prehistoric king because the alternative, that we simply don't know our own modern oceans, is almost more unsettling. However, the Mariana Trench and the surrounding abyssal plains are already inhabited by giants that don't require a leap into the Pliocene to explain. By looking at the anatomy of these known residents, we can begin to categorize the shadow in the footage, not by stripping away the mystery, but by grounding it in the terrifying reality of modern marine biology. The first and most likely candidate for many Megalodon sightings is the Pacific sleeper shark, Somniosus pacificus. This is a creature that seems designed by nature to haunt the deep. They are massive, sluggish, and possess a skin texture that looks like weathered stone or ancient sandpaper. While many people think of sharks as sleek, fast-moving torpedoes like the short-fin mako, the sleeper shark is the opposite. It moves with a glacial, rhythmic pulse that can look eerily similar to the heavy movement described in viral trench footage. They are known to reach lengths of over 7 meters, and because they live in such extreme conditions, their metabolism is incredibly slow. When a sleeper shark appears on camera, it doesn't dart, it looms. The sheer bulk of a large sleeper shark is what often leads to the Megalodon comparison. Because the water in the Mariana Trench is so clear and lacks a fixed reference point, forced perspective becomes a major factor. If a 7-meter sleeper shark swims closer to the ROV's lights than the bait cage, it can easily appear to be 15 or 20 meters long. Furthermore, these sharks have a blunt, rounded snout and a thick, cylindrical body that mimics the reconstructed silhouette of the Megalodon. They are the true titans of the cold, capable of diving to depths of at least 2,000 meters and potentially much deeper. They are scavengers and predators that embody the slow and steady survival strategy required for life in the Hadal zone. Another regular inhabitant of the deep that defies our expectations of size is the blunt-nosed six-gill shark, Hexanchus griseus. Unlike most modern sharks that have 5 gill slits, the six-gill is a primitive lineage that dates back to the Triassic period. It is, quite literally, a living fossil. These sharks can grow to over 5 meters and have a massive, heavy-set head with a mouth full of comb-like teeth designed for sawing through large carcasses. When a six-gill appears in deep-sea footage, its glowing, emerald-green eyes and prehistoric movements create an immediate sense of dread. It looks like something that shouldn't exist in the modern world, which is why it is so frequently mistaken for a baby megalodon or a surviving prehistoric relative. Beyond the sharks, we have to consider the biological anomalies of the deep. The phenomenon of abyssal gigantism we discussed earlier doesn't just apply to isopods and squid. It suggests that there may be species of fish or rays that reach sizes far beyond what is recorded in scientific literature. We are talking about a region of the planet where we have only sent a handful of manned submersibles and a fraction of the necessary ROVs to get a complete census. If a supergiant version of a known species exists, the Mariana Trench is exactly where it would hide. The footage we see might not be a megalodon, but that doesn't mean it isn't a monster in its own right, a biological outlier that has broken the records of its own species. The way these creatures move in the footage is also a key piece of the puzzle. In the vacuum of the deep, movement is about energy conservation. A megalodon in the shallow Miocene seas would have been an active, high-energy hunter. But if that lineage moved into the trench, it would have had to adopt the sleeper strategy. It would become a ghost that drifts rather than swims. This creates a visual overlap between a prehistoric survivor and a modern deep-sea shark. Both would evolve toward a similar form: massive, slow, and dark, because that is the only blueprint that works at 11,000 meters. This is known as convergent evolution, where different species develop similar traits because they are facing the same environmental pressures. There is also the matter of the bait cage footage that often accompanies these claims. In many of these videos, a large shark is seen bumping or investigating a metal cage filled with bait. To the casual viewer, the shark looks large enough to swallow the cage whole. However, when marine biologists analyze the frame-by-frame movement, they often find that the shark's gills and fin placements match a sleeper shark or a large Greenland shark. These species are known to live for centuries. The Greenland shark can live for over 400 years. This means that a shark caught on camera today could have been swimming in the ocean during the height of the Renaissance. That kind of longevity gives these creatures an ancient aura that is easily confused with prehistoric survival. However, even with these identifications, there is always a margin of error. Scientists are the first to admit that our records of the deep are incomplete. Every time we send a camera into the trench, we see something we've never seen before. We see snailfish living at depths that should chemically chemically dissolve their bones. We see jellyfish that look like floating psychedelic lamps. If the ocean can hide these things, why couldn't it hide a predator that has simply changed its shape and its habits to survive the end of its era? The identification of a sleeper shark or a six-gill doesn't necessarily close the case. It just broadens our understanding of what large really means in the abyss. We are left with a choice between the known and the unknown. We can look at the shadow and see a well-documented, albeit massive, deep-sea shark. Or we can look at that same shadow and see the potential for a lineage that refused to die. The footage serves as a mirror for our own curiosity. It challenges us to define the line between a modern animal and a prehistoric myth, and it reminds us that in the darkness of the trench, the two might look exactly the same. If these giants are indeed modern species, it raises an even more compelling question. How much more is down there that we haven't even caught a shadow of yet? This leads us to the most famous precedent for a lost creature returning from the grave: the ocean's secrets. The most powerful argument for the existence of a hidden giant isn't found in grainy footage, but in the history of a fish called the coelacanth. For decades, the scientific community held a firm, unwavering stance. The coelacanth had gone extinct 65 million years ago, vanishing alongside the dinosaurs. It was a closed chapter in the Book of Life, supported by a total absence from the fossil record in any recent strata. That changed in 1938, when a museum curator in South Africa spotted a strange blue, limb-like fin poking out of a local fisherman's catch. The extinct fish was back, and it hadn't changed much in millions of years. This discovery sent shockwaves through the world of biology. It proved that a species could survive for eons without leaving a single trace for us to find. This is known as a Lazarus taxon, a group that disappears from the fossil record only to reappear much later, alive and well. The coelacanth didn't survive by being the strongest. It survived by staying in deep, stable environments where the chaotic changes of the surface world didn't reach. It found a niche in the shadows and stayed there, unnoticed, while the rest of the world moved on. If a 4-foot fish could pull off a 65 million year vanishing act, the question of whether a megalodon could do the same over a much shorter 3 million year window becomes significantly more interesting. Critics argue that a megalodon is a massive apex predator, not a small cave-dwelling fish, and would therefore be impossible to miss. However, this assumes that the megalodon stayed exactly as it was. If the lineage followed the coelacanth's lead and retreated into the deep, it would have entered a realm where human observation was non-existent until the last century. We are effectively looking for a needle in a haystack that is 7 miles deep and covers the majority of the planet. The ocean's ability to hide its residents is a matter of pure geography. While we have mapped the surface of Mars and the Moon with incredible precision, our maps of the ocean floor remain largely topographical and low resolution. We know where the mountains are, but we don't know what is living in the valleys between them. The Mariana Trench is just one of many Hadal systems, deep trenches that act like isolated islands in the abyss. Each one could theoretically host its own unique ecosystem, or serve as a refuge for species that the rest of the world forgot. The coelacanth precedent teaches us humility. It reminds us that our certainty about extinction is often just a reflection of our limited perspective. When we look at the footage from the trench, we are looking through a keyhole into a room the size of a cathedral. We see a massive shape, and our first instinct is to rationalize it using the small amount of data we have. But history shows that the ocean doesn't always play by our rules. It keeps secrets. It preserves lineages. This doesn't mean every shadow is a prehistoric monster, but it does mean the door is never truly closed. The ocean is a three-dimensional labyrinth, and the deeper you go, the more the rules of time seem to bend. The coelacanth proved that extinction is not always final. Sometimes it's just a long game of hide and seek. If the ocean can hide a prehistoric fish for 65 million years, what else has it tucked away in the corners of the map where the pressure is high and the light is gone? It suggests that our current understanding of the deep-sea food chain might be missing its most significant link: our relationship with the abyss. We live in an era where every square inch of the Earth's surface is indexed by satellites, and every forest is tracked by GPS. We have mapped the human genome and landed rovers on distant planets, yet the ocean remains the only place on Earth where a true monster could still realistically hide. The persistence of the Megalodon in our cultural consciousness is a testament to our need for a final frontier. The Mariana Trench serves as the ultimate blank canvas for our fears and our wonder.
It's the Mariana Trench and is a huge crescent-shaped expanse of sea that holds the title as the deepest section in the Earth's seabed.
Psychologically, humans are uncomfortable with a vacuum of knowledge. When we see almost 100% of the ocean floor labeled as haven't visited, our imagination rushes in to fill the gap. In ancient times, mapmakers would draw serpents and dragons in the blank spaces of the sea, labeling them with the warning, "Here be dragons." Today, we don't draw dragons. We look at ROV feeds for the Megalodon. The creature has become a modern myth, a symbol of the untamable power of nature that exists beyond the reach of human technology. Human curiosity also stems from the Cozumel effect, the thrill of the prehistoric survivor. There is something deeply romantic and terrifying about the idea that while humanity was building cities, fighting wars, and developing the internet, a 30-million-year-old predator was quietly patrolling the darkness, completely indifferent to our existence. It humbles us. To suggest that the Megalodon is still out there is to suggest that we do not own this planet as much as we think we do. It represents a part of the world that hasn't been tamed or commodified. The viral nature of these videos also highlights our relationship with digital evidence. We are a visual species, and in the age of high-definition streaming, we demand to see the mystery for ourselves. However, the deep ocean is a master of illusion. The way light scatters in the water, the lack of scale, and the eerie, slow-motion physics of the abyss create the perfect environment for pareidolia, the tendency to see familiar patterns or famous monsters in random data. We want to see the serrated teeth. We want to see the massive tail. Every grainy frame becomes a Rorschach test, where our desire for discovery battles our scientific skepticism. But there is a darker side to this fascination. The monster in the water reflects our own anxieties about the environment. As we witness the rapid changes in our climate and the decline of surface species, the idea of a prehistoric survivor hidden in the trench offers a strange kind of hope. It suggests that nature is more resilient than we give it credit for, that somewhere in the deepest, coldest part of the world, life is carrying on as it always has, protected by miles of water and crushing pressure. Well, the shadow in the footage is a bridge between the world we know and the world we fear. Whether it is a sleeper shark or a surviving megalodon, the reaction is the same: awe. We are drawn to the abyss because it is the only place left where the rules of the modern world don't apply. It is a sanctuary for the unknown, and as long as the trench remains dark, the Megalodon will continue to swim through the corridors of our collective imagination. It is a reminder that the most terrifying thing about the deep ocean isn't what we find, but what we have yet to discover. The footage from the Mariana Trench remains a powerful reminder of how little we truly know, whether that massive shadow belongs to a modern giant or a prehistoric ghost. Its presence proves the abyss is far from empty. We are left with a mystery that bridges the gap between ancient history and modern discovery. As long as the deep stays dark, the legend of the Megalodon lives on, patrolling the final unexplored frontier of our planet. Stick around as we continue to track the secrets hiding in the deep. Subscribe to join our next descent into the unknown. Thanks for supporting us.